Okay, this is stats, and in this video we will be talking about z-scores from section 2.1, chapter 2, section 1. So, z-scores. So what does it say? Let's return to data from Mr. Pryor's first statistics test. So this is the data that came in the STEM plot where we were first identifying percentiles. So I think it was it Jenny? I think it was Jenny, wasn't it? Yeah, Jenny, right? This was the data from Jenny. This was the scores, right? And now this is very difficult to read, so I'm going to have to write these in. So N means the number of values. So we had 25 scores. The mean for this was 80. In case you can't see. The median was also 80. Really? Oh, that's convenient. This is the true mean, which we're not really concerned about. The standard deviation is we are concerned about. It's about 6.07. The minimum, the maximum, Q1 and Q3. It's not really going to concern us right now. So, but the important thing is, in here, we're going to need the mean. We're going to need the standard deviation. So, the question is, here's the numerical values, okay? Because Jenny's score of 86 falls relative to, so the question is, where does Jenny's score of 86 fall relative to the mean of the distribution? Because the mean score of the class is 80, we can see that Jenny's score is above average, but how much above the average is it? So we have a mean of 80, her score is 86. The standard deviation, okay, so I'm going to draw this really quickly so you can see what I'm talking about. So I'm going to pretend I'm doing a box plot. Just bear with me for a second. So let's say your mean of 80, all right, your standard deviation was 6.07. So it means 6.07 out here or 6.07 out there. Now, her score of 86 actually falls just a little bit below 86.07. Her score would fall somewhere just down over here. Somewhere, well, it's probably even closer than that. Her score of 86 would be right there. So we say, we say, since 6.07 is the standard deviation, this standard deviation is, she is within, so okay, I'm going to have to write this down. Jenny is within 1 standard deviation away from the mean, away from Jenny is within 1 standard deviation away from the mean. Because 1 standard deviation would be 6.07. Okay, let's say you went out another 6.07, because that's where this is going to end up going. Let's say you went out another 6.07, and then another 6.07. Well, now you would be, any score between here to here would be within 2 standard deviations. Let's say you went out another 6.07 and another 6.07. Then you'd be within 3 standard deviations. So every 6.07 is considered 1 standard deviation. If you are over here, let's say, where my finger's at right now, you would be within 3 standard deviations above the mean. If you are here where my finger's at right now, let's say you were down here, okay, you would be within 2 standard deviations below the mean. All right, so it just depends on where you are. If you were right where my pen is right now, you'd be within 1 standard deviation below the mean. If you were where my pen is right now, you'd be within 3 standard deviations below the mean, 2 standard deviations below the mean, and so on and so forth. Right? Every 6.07, think of that like your interval on a histogram, you're going 1 more standard deviation up. But Jenny, who's at 86, is within 1 standard deviation away from the mean, so I should really say above the mean. Okay, now, why do we want to know that? Well, because we want to know, just like in percentiles, we want to know where we stand with a specific score. So if she scored an 86, we know from the previous problem that she scored what did she get on her percentile? An 84. She was in the 80. She was at the 84th percentile, and she is within one standard deviation away from the mean. It's just a different way to describe her location. All right, you have percentiles, and now you have, what you're going to have is something called a z-score. Now, what we want to do is calculate a person's z-scores. And the z-score tells us how many standard deviations from the mean an observation falls and in what direction. So instead of me sitting here and plotting, the mean and then figuring out what the standard deviation is and then roughly estimating about where this person's at, we can do this very quickly using just some 2 or 3 bits of information. So here is how we're going to calculate something called the standardized score or the z-score, because we want to know how far away from the mean an observation falls. Remember when I said Jenny was within the one standard deviation? Well, where exactly? Is it at 0.8? Is it at 0.999? Like, how close is she to really being at one standard deviation? What about a person who's over here? How much in that standard deviation, how far away are they? Are they at 2.5? 2.35, 2.4? So where exactly are they? We want to know specifically. All right. And here's how you calculate this. It's called the standardized score of something, and it tells you how far away it is from, or how many standard deviations it is from the mean. So if x is an observation from distribution, also known as the mean, the standardized deviation or the standardized score of x is calculated the following way. You get your answer, or your z-score, is equal to the value, your observation, right? In this case, her score, subtracted from the mean, all divided by your standard deviation. Okay? So your observation subtracted by your mean, all divided by the standard deviation. So we're going to do this on this example. So Jenny's z-score, or her standardized score, is equal to, she got an 86 subtracted by the mean of the scores, which was, in this case, was 80, and the standard deviation was 6.07. All right, well, that shouldn't be too much of a problem. 86 minus 80 is a 6. 6 divided by 6.07 should give you a z-score of I have no clue. 6 divided by, clear. Hey, go back. Oh my goodness. How in the world? Oh, good Lord. 6 divided by 6.07. She has a z-score of 0.988. I'm going to go to 4 decimal places. Sorry, guys. 5. All right. Now, she is almost at a z-score of 1. That, if you had gotten a z-score of 1, that would be 1 standard deviation, right? But she's almost there. She's not really quite there, but she's well within. If you do 1 subtracted by 0.9985, you're, 0.02, whatever it is you're at. And that should make sense, since she really just scored she's at 6. 86 minus 80 is at 6, not at 6.07. So this is her z-score. This is where she is at relative to the standard deviation. I'm sorry, this is her standard deviation for how far away she's at from the mean. That's the best way to say it. It makes more sense in my head once you get the picture of it. But that would put her at almost at 1 standard deviation, but not quite. But she is within 1 standard deviation. Okay, so we're going to do the same thing for the next example, which is Mr. Pryor's test. Katie, who scored a 93, and Norman, who earned a 72. So we're going to find their z-scores. All right, we're going to see how far away from the mean is their standard deviation. Okay, so let's do Katie first. Katie has a score of 93. Okay, so we have the Z is going to be your observations, right? Minus your observation of 93 minus your mean, which is in this case 80, divided by the standard deviation, which is set in the, based on the information, 6.07. This is A. So we have 93 minus 80 should give us, what is that, 13 divided by 6.07. So Z would be equal to 13 divided by 6.07. So that would give us a Z-score of 2.14. Let's say 2.142. Okay. So she is past the second standard deviation and just a little bit past the second standard deviation. So if you go back to, this is Katie. I think this is Katie. Okay, so Katie would be, so this is one standard deviation. This is a second standard deviation. So Katie would fall somewhere over here. All right. That's her, that would be where her Z-score was. One standard deviation, a second standard deviation. Okay. Okay. And then just a little bit past. Now we have, what's his name? Norman. Norman's Z-score would be, he earned a 72 minus the mean divided by 6.07. 72 minus 8 should be a negative, what is that, negative 8? Yes, negative 8 divided by 6.07. All right, so this is going to give us a Z-score of, I don't know what that is. 8 divided by 6.07 gives us negative 1.32. I'm going to go negative 1.3218. We'll sit there. We'll sit there. Okay, so that means negative. We go to the left. So in this case, right here, one standard deviation, right? And then we go just a little bit past a quarter. So we go one standard deviation, not halfway, about just a little bit past a quarter. So this would be where Norman would be at. Okay, so it would be 1.318 standard deviations below the mean. All right, so those are your two problems for Z-scores. All right, just another way to calculate. We have percentiles and we have Z-scores. Where is your observational value fall within the data set? All right, and then for Canvas, all right, go to section 2.1, page 91, and answer the check for understanding questions 1, 2, 3. So if you want to combine them together or do separate, you could probably just combine them together and combine the answers for the first part 1 and then put it together with this part 2.